blocks, a hand plane, rivets, and pine tar. That is everything a Norwegian craftsman needs to create a world-class wave-gliding vessel. In today's video, we will witness every mesmerizing stage of this traditional craft, from leveling the keel using a spirit level and measuring timber by handspans, to the riveting technique that locks in perfect curves entirely without the aid of modern machinery. A truly spectacular experience for anyone passionate about raw mechanics and ancient woodworking artistry. Let's get started. At RaWMachines, craftsman Ingvald Sande is beginning the construction of a traditional Nordfjord boat measuring 8 Allen 8 inches in length. A pine log is selected as the primary material. From the raw timber, the craftsman begins shaping the joining edges, marking the inner and outer faces, and establishing the standard dimensions. An axe is used to taper both sides and create preliminary grooves. Next, a curved plane is used for fine adjustment, smoothing the surfaces and refining the transitions. The keel joint is carefully carved, and the entire component is continuously planed and adjusted until it meets the required specifications. Finally, the keel is placed on supports and checked with a spirit level. In traditional boat building, this is not merely a finished piece of timber, it is the backbone, the foundation that will determine the shape, balance, and soul of the entire boat to come. After the keel, the craftsman shapes the bow and stern, the components that define the boat's appearance and balance. The wood is flattened, straightened, and measured using traditional methods based on handspans and finger widths. The position of the lyrodden is determined, the point where the side planking transitions into the upper shear strake. Next, the bow and stern sections are marked, sawn into shape, and refined with an axe. The inner face is about 1.5 inches thick, while the outer face is thinner to create a more graceful profile. From these rough timber blocks, the first recognizable form of the fairing gradually emerges. With the primary components ready, the fairing enters the critical stage of framing and raising. The keel is laid down first, followed by the raising of the stem and stern posts, establishing the initial outline of the vessel. The scarf joints are sawn and meticulously adjusted to ensure every single component fits tightly together. The boat builder continuously shaves the hood ends, adjusting them to fit flush against the keel while maintaining the exact required thickness. Temporary nails are driven in, not for permanent fastening, but to stabilize the structure during the alignment process. As the overall shape begins to take form, the process of sealing the joints is carried out. Tar mixed with sawdust or fine powder is applied to the mating surfaces, after which tarred moss or hemp fibers are laid into the seam before the wedge clamps are driven home to tightly lock the entire assembly. This is a simple yet highly effective traditional technique, ensuring that the joints between the keel, stem, and hood ends become incredibly strong, perfectly watertight, and fully prepared for the subsequent layers of planking. After the framework is erected, the joints are secured with rivets. The craftsman continues refining the keel, bow, and connections to create a continuous curve along the hull. But boat building is not simply about joining wood. It is about creating the correct line of the vessel. Using a plumb line and center measurements, the craftsman checks the boat's axis, ensuring the structure remains straight and balanced. Next, the ronin, the characteristic upward curve of the hull, is established. The forward section measures about 30 to 32 inches deep, while the aft section is slightly lower. The finished curve rises approximately 10 to 12 inches deeper than the main hull line. These proportions determine how the fairing floats, glides, and responds to waves and wind. Finally, the interior dimensions are checked one last time. The framework now clearly reveals the shape of a boat ready to enter the hull building stage. You can see Ingvald sawing the bottom planks near the stem and stern, keeping the thickness at the back to about 2 inches. The marking lines are not entirely reliant on rulers, but are often trued by eye, a skill forged only after decades of working the trade. Nowadays, a bandsaw can assist in roughing out the initial shape, but in the old days, this entire task was executed solely with an axe. The boat builder hews the mating edges, continuously testing and trimming to ensure the bottom planks fit with absolute precision against the hood ends, the stem, and the keel. Once the basic shape is established, the work transitions to adjusting the bevel. This stage demands a highly developed sense of form, as most of it is executed entirely by eye. Even a minor deviation in the bevel angle can completely distort the hull's overall curvature. Hand planes and draw knives are used to fine-tune the surface. Following this, the builder fashions the scarf joint, which measures roughly 3 inches in length. The inner face is sawn first, with the outer face finished afterward. The scarf is typically carved slightly concave, a small but critical detail that prevents the wood from bulging when the rivets are tightly clenched. Before installation, the excess wood on the outer face is shaven off, and the rivet locations are carefully marked out. The connections to the hood ends utilize standard boat nails, while the joints joining the keel use iron rivets to achieve a higher degree of structural strength. Tar is brushed onto the mating surfaces, followed by a layer of tarred moss or hemp fibers laid into the seam to create a watertight seal. With everything in readiness, the bottom plank is clamped tightly into position and permanently secured. From this moment on, the bottom of the fairing ceases to be a collection of individual boards and becomes the true unified foundation of the entire vessel. When the bottom plank fits into place, rivets are driven along the keel to lock the framework together. The craftsman uses a self-holding riveting hammer to control hand force, ensuring the joints are strong and uniform. Next comes the installation of the lower side planks. The joints at both ends are prepared first to achieve a precise fit. Although wood is normally soaked in seawater to make bending easier, this step must be limited because there is no extra joint allowance left for adjustment. Clamps, joint clamps, and bevel gauges remain constantly in the craftsman's hands. They continuously check, fine-tune, and only then secure the pieces with rivets and washers. Through each operation, the planks gradually press tightly into the curve of the hull. With the first strake firmly secured to the hull, the work advances toward the bow and stern sections of the planking. The rivet runs have been prepared beforehand, while the surface of the first strake is meticulously planed to create a flawless mating surface for the subsequent layers of planking to rest upon. The gains at the ends of the bottom planks undergo numerous adjustments before the hood ends of the side strakes are hung into position. It is precisely this dramatic sweep at the stem, combined with a subtler rise at the stern, that creates the unmistakable signature silhouette of the fairing. Clamps hold the entire assembly tightly in check during alignment, while the plank, flexing under the natural tension and elasticity of the timber, gradually coaxes itself into its true, intended shape. Finally, the bow and stern strakes are brought flush into a seamless fit, with additional exterior shores positioned to reinforce the overall stability. At this stage, the lines of the hull have emerged with striking clarity, elegant, balanced, and embodying the full distinctive beauty of a traditional Nordfjord boat. As the hull takes shape, the craftsman begins defining the interior space. The seating compartments are divided according to traditional measurements, about 32 inches wide, with the forward compartment typically nearly 1 foot longer than the aft section. These proportions do not merely create seating space, they also determine the boat's balance and load distribution. Next, the ribs are test-fitted, marked, and carved until they conform tightly to the hull planking. Every component must fit exactly where it belongs. Even the method of fastening follows its own rules. Nails are placed close to the joint edges rather than in the middle of the plank to reduce the risk of splitting the wood. This is the kind of craftsmanship passed down through generations, where durability comes from a deep understanding of materials and structure. The work now shifts to preparing and hanging the upper shear strakes at the bow. The builder begins by sawing deeply into the lie rodden position, while simultaneously continuing to refine the gains at the hood ends of the bow planks to prepare for the new joint. Using clamps to hold the plank firmly in check, the craftsman adjusts the timber while feeling the seam by hand, checking if the fit is flush enough and if the curvature matches his intent before reinforcing the structural assembly to the required standard. Next, he utilizes a bevel gauge to verify the flare angle of the strake. For an experienced master, a single glance is often enough to judge this, but the measuring tool confirms the result and accelerates the alignment process. Once everything is perfectly seated, the upper shear strake is secured with rivets, completing yet another vital section of the hull. At this stage, the builder begins marking out the gunnel rub rails before sawing and trimming them to match the exact required profile. Simultaneously, the wooden gunnel pins are handcrafted and shaped. Prior to bending, the rub rails are soaked in water for 2 days and nights to maximize their flexibility. Afterward, the craftsman bends them along the contour of the hull, drills the holes, and drives the wooden pins into position. Without the need for complex metal fasteners, this joint system holds with astonishing strength, a testament to the sheer efficiency of traditional boat building techniques. Once the gunnel rub rails are positioned, the builder uses an axe and hand plane to finish them directly inside the hull, making it easier to monitor the joints and match the actual curvature of the vessel. Next, the L-shaped frame timbers are fitted, extending from the lower bilge up to the main shear strake to increase the rigidity of the entire upper topside. Using a bevel gauge to determine the flare of the main shear strake, the craftsman hews the timber to fit perfectly against the framing system. The lower struts are then installed in sequence, including one positioned between the L-frames. Afterward, the rib is bent over to the opposite side and secured to the rising timber, completing the reinforcement unit composed of the L-frame and its accompanying cleat. Final adjustments are made with a small axe and a short block plane, so that every detail tightly hugs the hull. With the reinforcement system complete, the builder measures the length of the main shear strake, ensuring it extends past the aft frame assembly. The planks are marked, shaped, and planed smooth, while the top edge of the upper shear strake is also meticulously refined. Because the main shear strake stands at a steeper angle than the other layers, a portion of the overlapping edge is planed down to achieve the necessary tight fit. The forward and aft planks are test-fitted in order, leaving the stem and stern sections to be treated last. At the stern, the plank is clamped in place to verify the flare and mark the mating edge, before being removed for further cutting, planing, and dressing of the gains at the hood ends. Finally, the main shear strake is completely finished. A rounded gunwale cap rail is mounted along the topmost edge, running the entire length of the hull and secured with screws. This acts as both the final structural reinforcement and the defining finishing line, giving the traditional Nordfjord fairing its characteristic elegant yet robust silhouette. With the primary structure complete, the boat builder turns his attention to the interior fittings. The rowing system is installed first. The oarlocks are tailored to the contour of the hull, reinforced with oarlock blocks, and finished by drilling the holes for the oar straps. The bow section undergoes further trimming, while the floorboards are crafted and assembled using familiar tools, an axe for rough shaping and a hand plane for finishing. Finally, the seating system is put in place. Once the floorboards are complete, the builder cuts the mortises for the thwarts to rest securely upon the interior stringers of the hull. The forward thwart and the stern seat are fitted in turn. From this moment on, the fairing is no longer just a completed wooden structure, but a true vessel, ready for her crew to step aboard, take up the oars, and guide her out onto the water. In the final stage, the boat is turned upside down to treat the outer surface. The exterior woodwork is scraped clean, planed smooth, and given a definitive refinement. The stern hood ends and subtle transitions are also finished to ensure a perfectly balanced whole. Lastly, a traditional coat of pine tar is brushed over the wooden hull. This not only gives the vessel its characteristic rich color, but also protects the timber against harsh weather, moisture, and the elements of the open water. A fairing is never truly complete without its oars, the direct connection between the rower and the water. The length of the oars is determined by a traditional rule of thumb, doubling the beam of the boat and adding the length of the handle. From the initial wooden blank, the builder saws out the shape, then uses a hand plane to refine every line until it is balanced and comfortable to hold. The handle is further finished using an axe, a pocket knife, and sandpaper. Finally, the oar loops, traditionally known as hamley, are crafted. These are typically fashioned from flexible birch roots or branches, bent into loops to keep the oars securely in place during use. Although rope or wire is sometimes used as a substitute today, natural materials best reflect the true spirit of traditional boat building, making resourceful use of whatever the surrounding forests and land provide. After a long series of measuring, carving, and assembly stages, the fairing is finally launched. The boat is turned upright, lowered into the water, and put through its trial run, a moment that always carries special meaning for the boat builder. With the participation of neighbors, the test quickly proves the success of the entire process. The boat performs steadily, maintains its intended form, and meets the original expectations. From rough timber in a small workshop in Gloppen, the traditional fairing is now ready to return to where it truly belongs: the water. The Pacific Northwest is home to some of the world's most colossal timber. However, if these giants are felled directly from the base, the sheer impact of the massive crown crashing to the forest floor would shatter and ruin the structural integrity of the timber. Because of this, a precise and specialized step is required before the tree can be felled, topping the tree. This task falls to John Levitt, a professional high climber. Over his 20-year career, he has topped more than 3,000 trees to be used as spars and masts. John shares that he loves the thrill of conquering heights and the challenges that come with the job. To carry out the mission, John equips himself with climbing spurs, a safety harness, an axe, and a chainsaw strapped to his side. He begins his ascent up the hundreds of feet tall ancient giant, tossing his flip rope and driving his spurs deep into the thick bark.
On entend le lingot.
As he climbs higher into dense fog, John uses his axe to clear away branches obstructing his path. Afterward, he fires up his chainsaw to limber the trunk. Maintaining balance and operating heavy machinery at this altitude demands absolute, laser-sharp focus. The moment at the very top is a convergence of silence and explosion. As John's chainsaw slices completely through the apex dozens of meters above the ground, the massive crown plummets toward the earth. Instantly, the sudden release of weight transforms the remaining trunk into a colossal spring, violently whipping and bucking back and forth in midair. He must hold on with everything he has, placing absolute trust in his safety gear until the tree finally settles. As the trunk gradually comes to a standstill, the most hazardous part of the operation is over. The massive timber is now secure, standing tall, straight, and clean like a majestic mast against the sky, fully prepared for the final felling at the base to begin its epic journey toward the shipyard. Here, the massive log will be carved and shaped to transform into a dugout canoe. First, the craftsman uses a sharp iron spade, applying full leverage to pry away large sheets of bark, exposing the bright heartwood beneath. Far from just cleaning the surface, this is a critical inspection step that helps detect any cracks or knots that could compromise the structural integrity of the canoe. Once the log is stripped bare, a chainsaw is brought in to make long, deep longitudinal rips running down the multi-meter length of the trunk. When the cuts reach the proper depth, the craftsman begins driving hardwood wedges into the seams. This process demands absolute precision to ensure the split surface parts cleanly without twisting. From the 2 raw wood slabs obtained after the split, the craftsman begins tracing the vessel's outline. A tape measure is stretched taut to establish symmetrical points along the hull. With the aid of a high-power electric planer, the surface layer is leveled to eliminate any rough ridges. Next, a chainsaw glides artistically to shave off excess blocks at both ends, carving out the tapered, hydrodynamic shape of the bow and stern. This is a critical phase that dictates the future dugout's ability to slice through water and ride the waves. This is the most sweat-inducing and labor-intensive stage. The craftsman uses a chainsaw to make cross-cutting grid lines, creating a network of deep relief grooves inside the timber. Following this, an adze, a traditional hand tool with a characteristically curved blade, takes center stage. Powerful strokes pry loose the remaining chunks of wood, gradually deepening and widening the hull's interior. The synergy between modern machinery for bulk removal and the traditional adze for refining the soft contours of the interior showcases the sheer finesse of this craft. The hull is flipped upside down to work on the exterior shell. The craftsman utilizes a combination of planers and specialized draw knives to shave and sculpt the gunnels to perfect symmetry. This is when the artisan must rely on a keen intuition for thickness. If the hull sides are too thick, the canoe will be heavy and sluggish. If they are too thin, the wood will easily crack under hydraulic pressure. Layer after layer of paper-thin wood shavings fall away until the hull achieves a sleek, graceful lines without sacrificing its robust strength. Once the shape reaches absolute precision, the finishing stage begins. The craftsman uses scrapers and hand planers, patiently working over every single centimeter of the surface to erase the rough tool marks left behind from the bulk carving. Next, the edges along the gunnels are smoothly rounded over, not only providing a comfortable grip, but also adding a refined touch to the canoe's profile. The bow and stern are given a final, sharp carving to maximize their water-cleaving efficiency. Finally, a coat of natural oil or liquid tar is applied, bringing out the luxurious, striking grain of the oak. This coating does not just deliver a polished look worthy of a work of art, it penetrates deep into the wood fibers, creating a durable protective barrier against weather and water erosion. After weeks of dedicated labor, the canoe is finally launched into the water. It glides effortlessly through swift currents, navigating rocky rapids with remarkable agility. The vessel's rock-solid stability, while carrying 2 to 3 people along with their gear, stands as definitive proof of the success behind this meticulous crafting process. Next, join me as we visit the boatyard of Jimmy Fury. Jimmy Fury lives in Mount Plunkett, on the shores of Lough Ree, along the River Shannon. He balances life as both a farmer and an eel fisherman, a lifestyle that has given him a profound understanding of the aquatic environment. Craftsmanship has been woven into Jimmy's family for generations. His father was a carpenter, and his grandfather maintained and operated boats on the bay. Yet, Jimmy's entry into boat building happened quite naturally, starting with repairing his family's own vessels before gradually moving on to building his very first boat from scratch. According to Jimmy, a fisherman sometimes understands a boat better than a carpenter does, because they know exactly how the vessel needs to behave on the water. For him, boat building is not an art of straight lines, but an art of curves, where even the slightest adjustment can dictate how a boat glides across the River Shannon. The construction process begins with the keel, the component considered the backbone of the entire structure. Jimmy uses Irish larch to craft the keel for this standardized 18-foot sailboat. The keel is firmly secured onto the building berth, serving as the foundational bedrock for all the subsequent steps. Next comes the installation of the hog, which is fitted over the keel. This component creates the central slot required for the dropboard lifting mechanism. In tandem with this, Jimmy fits the stem post, the curved timber that shapes the bow and dictates the forward transitioning profile of the hull. Because this vessel belongs to a strict one-design class, it is constructed based on exceptionally rigorous measurements and technical specifications. A wooden guide batten extends along the overhead workspace, marked off in feet, to indicate the exact positioning of the stations. In this case, it marks where the temporary molds used for the planking stage are to be attached. The sheer strake planks are cut and temporarily clamped together so they can be worked on as a single unit, ensuring that the two symmetrical pieces are identical in shape. The planks are then brought into position and temporarily secured using the hog, ribbons, and a system of traditional wooden clamps. This stage demands constant adjustment to ensure the curves conform perfectly to the design. It is from this stage onward that the hull of the Shannon boat begins to emerge clearly, no longer just a technical framework, but gradually taking on the definitive shape of a real vessel. Though unmarried, Jimmy is far from alone. He has two brothers and two sisters. Among them, his younger brother Patty, a former naval sailor, became an important partner, supporting him both in daily life and later in technical work. Jimmy's path toward the Shannon 1 design began when two English customers approached him with a request to build a Shannon boat. Although he had never built this type of vessel before and did not yet fully understand its complexity, he accepted the commission, a decision that would become a turning point in his career. Fortunately, Jimmy received help from Walter Leving, one of the earliest Shannon boat builders. Walter did not keep the craft to himself, but shared molds, fittings, and technical knowledge, a spirit of mentorship, characteristic of the traditional crafts community. The Shannon 1 design itself carries a long history. The design dates back to the early 20th century when the first boats were built for the rowing community along the River Shannon. Walter Leving later built around 60 of them and continued working in the trade until as late as 1982. Now, as Jimmy completes each upper strake along the hull, he is not merely building a new boat, he is continuing a craft lineage that has endured for generations along the Shannon. To shape the boat ribs, Jimmy uses oak that has been soaked in water for several days to increase its flexibility before bending. The wooden strips are then placed into a steam system powered by local peat and fitted with a metal pipe as the heating chamber. The steam softens the wood fibers, allowing them to be bent to match the curve of the hull.
Right. You want to get some more ribs in here? Yeah, right. I hope they're better than the last ones. I'll keep it going for a while anyway.
This is not a task that can be done alone. Patty often assists Jimmy in positioning the heated timbers and securing them before the material cools and hardens again.
You ready, Patty?
Even a slight error in applied force or wood grain quality can cause a rib to crack.
Good. Yeah. In at the top, Patty. In at the top.
Once the ribs are completed, the hull continues to be assembled using traditional clinker construction, with overlapping planks fastened together by rivets. This method, originating from the Viking era, gives the Shannon 1 design its combination of lightness, strength, and suitability for the waters of the River Shannon. Once construction is complete, the boat will be inspected by official measurers appointed by the governing class association. The vessel must strictly conform to the exact technical standards of its design class. Even a minor discrepancy, such as a rib protruding too far or the hull width being off by a mere 2 inches, can result in disqualification. Jimmy must continuously monitor the alignment of the hull on the building stocks to prevent any twisting or a permanent list to one side. The beam of the boat, strictly regulated at 4 feet 10 inches, is maintained using temporary wooden shores, as the hull remains vulnerable to distorting before the permanent thwarts and seating are installed. Finally, the gunnels are fitted, adding structural rigidity to the sheer strakes and completing the overall hull structure. The design of the Shannon 1 design is deeply intertwined with the natural conditions of the River Shannon, an expansive Irish waterway characterized by short, choppy waves. As small sailboats and centerboard boats grew in popularity, racing regattas flourished, bringing with them intense debates over class uniformity and design advantages. To resolve these inconsistencies, the Shannon maritime community decided to establish a standardized, one design class exclusively for competition. The result was the birth of the Shannon 1 design, built to strictly regulated specifications. An 18-foot hull, a gunter rig, and a sail area not exceeding 140 square feet. In 1920, English yacht designer F.C. Morgan Giles was commissioned to finalize the blueprints, officially giving rise to the iconic class of the River Shannon. For Jimmy Fury, the Shannon 1 design is more than just a racing boat. It is a piece of Ireland, a part of the River Shannon, and a reflection of the very life he has been a part of for decades. Beyond building full-sized boats, Jimmy Fury also devotes considerable passion to crafting scale models. One of his earliest models was a Shannon 1 design, built at a scale of 1.5 inches to 1 foot. Work demanding precision and patience no less than full-scale boat building. He also created more complex models, including Swedish Iron Age boats.
Come on. Come on. Kitty. Go on.
But for Jimmy, the greatest challenge has always been the materials. The Shannon 1 design requires several different types of wood: Irish larch for the side planking, oak for the ribs, white pine for the decking, and mahogany and teak for interior details. To source timber that meets the required standards, he often has to travel extensively, with Cohen's Yard in Tullamore being one of his regular suppliers.
Right.
Throughout this process, Paddy continues to play a vital supporting role. Drawing on his marine engineering background and years of practical experience, he helps Jimmy operate the planer and handle many of the technical tasks behind the scenes in the boatyard.
It has to be dead straight, be right, isn't it?
Yeah. 90 degrees. There's only a few to bore, but so many.
I'd say you could go behind towards it there now, just there.
One of the critical technical features of the Shannon 1 design is the centerboard trunk. Situated right in the middle of the hull, this housing allows the centerboard to be raised or lowered as needed, giving the boat better tracking and preventing leeway when sailing close-hauled. Jimmy machines both side panels of the trunk simultaneously to ensure perfect symmetry. Even a minor misalignment could prevent the lifting mechanism from operating smoothly. During stages that require an extra set of hands, his neighbor, Peter Coyle, often stops by to assist. The remaining components are finished with equal care. Oak is steam bent to form the trunk capping, the steel centerboard is custom fabricated, and the bronze fittings are cast using traditional sand molds. Many of the tools Jimmy relies on are custom-made by his own hands, such as a specialized bronze compass plane used to shape the distinct taper and curve of the mast. After approximately 6 weeks of dedicated craftsmanship, the Shannon 1 design is finally completed and handed over to Donald Gleason. The final touches, including applying the protective coats of marine varnish, are completed to prepare the boat for its competitive debut on the racing circuit.
Well, it's better win plenty of races now, Jimmy.
For Jimmy, building a boat is about much more than just hitting the right dimensions or following blueprints to the letter. A true boat builder must understand how their creation behaves on the water, how it reacts to the wind, the waves, and the hands of the helmsman.
You brought it forward all the way on this, to the step.
Yeah.
But that's a good idea. In the plan it stops short, doesn't it?
Oh, it stops just here.
Yeah.
That is exactly what defines the enduring value of the Shannon 1 design. A balanced, elegant design that stands as a testament to a lineage of hand craftsmanship deeply woven into the history of the River Shannon.
If you make a
bit
float.
Jimmy Fury wears many hats in life: fisherman, farmer, carpenter. But above all, he is a boat builder. His love for the River Shannon extends far beyond the workshop. It lives in the exhilaration of hoisting the sails and helming the vessels himself out on the open water.
Here, Andrew, come in here. Andrew, come in here.
That one here.